So my name is John Ray. I'm a former 3CO in the Air Force. For those of you who are prior military, you might know what that means. For those of you who don't, it means I was a nerd when I was in the Air Force, and I'm still a nerd now. So after I got out of the military, I worked for a bunch of defense contractors, and that was really fun. And then I became a consultant with Shadowsoft. We are chef partners. We're a systems integrator. And what I do for them, in addition to the 80 other thousand hats that I have to wear, is I'm the chef technical lead. So what that means is that I take business problems and I figure out how I'm going to solve that problem with something based in chef. So that doesn't always mean that I'm going to write a bunch of code. Sometimes it means that I'm going to do things that are against best practice. Because let's face it, when you're trying to solve an organizational problem, there's more than just what's best practice you have to consider. So what that means is I move fast and break things so that my clients don't have to, right? I want to try out all the new stuff. I'm going to test things. I'm going to find something that works, even if it's not necessarily the official way to do something. So like 4 of us were in IA, so I'm not a security person, but this is the dilemma that we face when trying to implement security. If anyone was in Adam's talk earlier, you saw the IA as the dam preventing all of the water from getting through into production, right? And this is the dilemma that we face in the security and compliance world, that people just don't really like IA, right? They go, oh, security people, they're just here to make things difficult. They don't care about our enablement. We can't get along with them because they're archaic and they don't understand this new DevOps thing anyway. And really the funny part is a lot of people just go, well, we're just not really that vulnerable, so it's not really that big of a deal, is it? So who knows what this is? So this is the map of the WannaCry outbreak after 1 hour. These are the infected systems that showed up, just that we knew about after an hour, right? So everybody remembers this thing, right? Several 100,000 systems were infected, 150 countries, with a really old Windows vulnerability. Guess who has lots of really old Windows systems laying around? The federal government does, right? So one of the other things that has old Windows systems are healthcare companies and schools and these types of organizations. So when this attack hit the NHS in Britain, it shut down parts of the NHS. Like they had to reroute ambulances and go, I'm sorry, we're going to have to move your surgery to a later date. I can't get access to your patient records. So sorry, we're going to have to delay this appointment, right? So this is the same map 24 hours later. This is how fast this thing spread. Like everybody was vulnerable who didn't patch because Microsoft released a patch for it months ago, but we don't scan for these things. So what we have here is a situation that the internet and computer systems in general have become militarized in a way. The Air Force already classifies its computer network to the same level as it does its nuclear weapons systems. It's a weapons system in the Air Force. And so we have to take this seriously. We have to say, okay, well, if this is a weapons system and exploits are the missiles that we're going to use here, we have to come up with a better way than just being the dam that prevents things from getting into production, right? And so the challenge here is that things go fast. Systems change. Your configurations drift. And your boss comes to you and goes, hey, look, here's this new feature. I need it yesterday. And in the DevOps space, we tend to do this thing where we take brand new technology and we go, yes, let's use that new cool thing that I found on GitHub who's, was posted there by, Russian 475. It's like, yeah, let's do that. And so we take this idea of acceptable risk and we go, okay, let's push this as far to the extreme as we can go. Because we want this velocity. We want to go fast, right? And so when you talk about security and compliance and we talk about going fast, sometimes it just seems like they're at odds with each other. And there's nothing we can really do about that. And so we have to beg the question, like, are we always going to be the dam that prevents people from getting things to prod? And so we have this concept of security as code, right? And we had infrastructure as code, and that allowed us to produce infrastructure at an extremely fast pace, right? It was repeatable, and it was the same every single time, so we could blow things away and bring new stuff up. So why not security as code? Why not apply those same principles to the security world? And so what we find is that there has to be a better way. Like, we can't just continue to be that dam that prevents things from getting into production. And so what we're going to use is the chef compliance framework. So we're all at ChefConf. We've all heard about the compliance server and InSpec. We had great keynotes on it. There were great sessions on it earlier. The compliance framework is basically two pieces, right? You have InSpec, which is the language in which we describe security, right? And then you have the compliance server itself. And the compliance server or Chef Automate, now that a lot of these features are in a Chef Automate, provides you with a central location for profile storage, for running scans, for looking at reports, and getting a real good view of your infrastructure and what your security posture is within your infrastructure. So that's great. We know we have a problem. We know there are viruses out there. We know there are foreign agencies trying to attack us. We know we want to use the Chef compliance framework because Chef is awesome and we want to be awesome too. So we need some guidance, right? Like, how do we actually do this? And so in the government world, we get these fun things called the STIG, right? And the STIGs are documents that describe for you what a computer system is supposed to look like in the federal space. But not only that, things like systems architecture, like how your system is actually configured, is only part of it. So the STIGs themselves cover a vast variety of things. So you have the various Linux distributions that get covered by the STIGs. You have simple things like Firefox and Chrome. But you also have non-technical things. We have controls that say you will have a patching procedure, end of control. Like, they don't tell you how or what you're actually supposed to do. There's nothing there. So STIGs are kind of complicated. There's all these different classification levels and security levels, and, you know, are we going to do Mac 1 classified? Are we worried about just Cat 3s and Cat 1s? Like, do we really care about this? You know, we have vulnerability discussions, and we have rule IDs, and we have, you know, hey, you should actually do this to a system. And then we have things that say, hey, I suggest that you document your users. Okay, that's not really helpful, is it? So what we have learned is that when you have a big, huge process like this, like how do I secure my entire environment, how do I implement the STIG, what you find is that you can break things down into smaller pieces. And if you break things down into smaller pieces, what you end up with is a framework for your developers, your IA teams, your management to work within to ensure that you're able to secure your systems at velocity. And so these are the 6 things that we're going to break this huge problem down into. Okay, we're going to ingest new data. We're going to triage that data within our organization. We're going to write a specification for that data. Then we're going to write code. And this doesn't have to just be remediation code. This can be the actual application code, the actual installation code that we're going to write with Chef, right? We're going to develop that code. We're going to test that code everywhere, not just for does Chef do what I think it should do, but does Chef do what I think it should do, and is that in the context of my security profile? And finally, as an IA team, we have to be able to certify that what we did is truth, right? When the auditors come in, when your client comes in and says, prove it to me, you have to be able to prove that kind of thing. So what do we mean when we say ingest? What we mean there is, where do you get data from? Where do the STIGs come from? What was the result of my last security profile run? What are the new CVEs that have come out? What are the new technical limitations that I know about from the last time I did this process, right? So fortunately, the STIGs are super easy to find. If you guys haven't been out to the site here, we can go out and grab STIGs. We can grab SCAP data. If you're familiar with SCAP, you can grab that data as well. These are released quarterly-ish. And so we got all this data. We have collected it from our various monitoring systems and whatnot. Now we have to triage this data. And when we triage stuff, we don't mean go through the STIGs and decide which ones we care about the most. What we actually mean is that you have to go in through every single control, and you have to figure out, does this even apply to me? But not only does it apply to you, but how does it apply to you, right? So what happens is you have to involve your stakeholders. It's not good enough for you to just be the IA team and show up and say, you will secure. That's not good enough. Because what happens when you say, oh, the installation directory for product Y must have the following permissions? What happens when your organization goes, oh, that's great, we don't install product Y there, we install it some other place, right? So what happens there is that if you don't involve your Oracle database team, your WebLogic team, your operating system deployment team, if you don't involve those teams, then you're never going to be able to adhere to the spirit of the rule. And even though you would technically pass an audit, right, you're still actually vulnerable. You're still failing here. So this triage process is super, super important. The next thing we have to do is we have to write a specification. So for our purposes, a specification is the result of ingesting data from all of the different various sources that we have to ingest data from, triaging that data within our organization with all of the stakeholders to make sure that we don't paint ourselves architecturally into a corner, or to make sure that, especially in legacy groups where you have databases that have been deployed for an extremely long time, and then someone comes along and says, oh, we're going to STIG these systems now, and your engineers go, no, there's no way we can't do that because we've literally designed a system that won't allow that, right? So you don't want to paint people into a corner, so you have to triage it in your organization. And then you have to write a specification for it. And so what we're going to use for a specification is we're going to use Chef Compliance, and we're going to write a compliance profile that is going to describe for us exactly what we mean by security within our organizations. So Chef does a really good job of providing for us some baseline profiles to look at and some examples of controls. But what you'll notice is none of this says DISA or STIG or federal or anything government-wise on it. And so since we don't have any of that really laid out for us, all we have is kind of reference material, really. So where do we start here? So one of the cool things about InSpec, and the version of InSpec that comes with compliance especially, is that it has this plugin called SCAP. The InSpec SCAP plugin allows you to read SCAP data and convert it into an InSpec control. So it's really cool. You basically download your SCAP data, you stick it in a directory, and you're going to run InSpec SCAP convert, and you're going to give it a path to where your SCAP data is. Now here we remember that things are complicated. This is the kind of thing you have to figure out during your triage process. Where, to what level are we supposed to be classifying these systems, right? That's what that process is for. So we're going to tell it we want the mission critical classified profile here, and this is what you get, which is kind of a mess, really. So the InSpec SCAP command does a really admirable job of giving you a pretty good conversion. It's about 75, 85%. There are certain things that SCAP just can't do. It can't describe it in its language, and so we can't convert that. But the other problem is we get all these XML artifacts, and we get an impact of 10, which doesn't exist in InSpec. So, and we also get these things, these really crazy regular expressions that can give you lots of false positives. So this is great, but really and truly this is not helpful to us, because if I ran this, it would work, but the report that I would get back would be garbage, and I couldn't show an auditor this report, right? So we have to write well-written controls. So what do we mean here? When we talk about writing a well-written control, what we're talking about is four main things. It has to be clear. I should be able to look at the control and know exactly what and why I'm even writing this code. It should be informative. It should have the appropriate amount of metadata so that I can go look at it and that I can index it in my system. It should also provide information that's program specific. So if you install Java into a different directory, then we have to know that, right? So our controls need to be informative. Our controls need to be portable. Just because it works in environment A that's in the NIPRNet, when we pick it up and move it to the CIPRNet in environment B, now it doesn't work anymore. So that's not helpful. We need to make sure that the controls that we write are able to be used in all of the different environments that we have, so it prevents us from having to rewrite code over and over again. The other thing is it has to provide traceability, and traceability is a kind of an interesting thing. So a lot of times you will be in a situation where your client is going to ask you to prove why you did something. So traceability is this idea that you have to be able to trace your code back to a requirement or a source document. So I have to be able to trace this control back to either the STIG it came from or to a requirement that the customer may have given me, right? So really quickly, naming conventions, there's a lot of argument about should we combine controls, should we not combine controls, how do we name things? It is my opinion that when you create a profile, your profile should be the name of your STIG that you're remediating for. So if you are remediating for the RHEL 6 STIG, you name your profile RHEL 6 STIG. There's no point in making it complicated. When you name your controls by STIG ID. Yes, this means that you are going to rewrite some code, because this means that for SSH, for instance, that has 8 different controls, you're going to have 8 different controls for SSH, right? The reason you do this is because of the amount of metadata that we're going to include in the control would dictate that you would have to split out your controls individually anyway. And if you write all of your controls into something called ssh.rb, you can't look at that and know what it means. You have no idea what that means. And so now you have to maintain an additional document that shows the mappings between STIGs and your special naming convention that you've come up with. So for the sake of ease, and so that lots of people can do this, this is how we're going to name things. So the first thing you get in a profile is an inspec.yaml, and if you're not going in and updating your inspec.yaml, you're doing it wrong. And this is because, again, we have to provide traceability, and we need to keep track of version numbers for things. So the top stuff is pretty standard. This description field literally came off the front page of the STIG document itself, down to the version and release information from that document. So by reading this, I have contact information for DISA, I have exact version of the document that I looked at to generate this stuff, and then we have our version, and this is important because when you update controls and you update your profile and somebody goes, oh, let's scan this, and they scan it with the old version of the profile, they may not catch things. So it's important to keep that updated, just like your metadata.rb in your chef recipes. So all controls start with a title. Fortunately, all STIGs also have a title, so we can literally rip and replace. So we're going to grab the title straight out of the rule, and we're going to put it into our control. So the top title is your long description. Okay, these sections matter for how the report looks in compliance. So the top section is your long title. How I title these is the STIG ID followed by the title. I title my control by STIG ID. You'll remember there's a short title inside of your STIG ID as well, and you'll see that I just take the same information and copy it down. The next thing you get is an impact. So impact is great. We had a 10 impact on our converted SCAP thing, which doesn't mean very much to us. So impacts actually have zero to do with impact and everything to do with a criticality level within chef compliance. The way that chef compliance reports whether something is a major problem, a minor problem, or a, oh my God, you should shut everything down and fix this right now problem. So it's a float number. We have these real weird mappings, and for us, what we're going to do is we're going to ignore all this, and we're going to map these to sev codes. So severity codes, category 1, 2, and 3. It's really, really easy. 0 to 0.4, cat 3, 0.4 to 0.7, cat 2, 0.7 to 1, cat 1. But that's even kind of complicated in and of itself, so we're even going to make it easier. You're only going to use 3 numbers. You're going to use 0, 0.5, and 1. That's it. There's no reason to use any other numbers but those, because there's only 3 levels of criticality within chef compliance. So we have a good impact now. This is a category 3 issue, and so we can mark our impact at 0 here. The next piece of a well-written control is the description. And the description is very important because it provides people with a very succinct way to see what are we doing? Like, why are we doing this? Like, I need to know, and I need to know without being able to go look at the STIG document, right? So we're going to include a description. Fortunately, STIGs also include descriptions. So we can, again, literally rip and replace out of the STIG and provide this information to our auditors, to our developers, to the rest of the IA teams to look at this and say, why are we doing this, right? So the next piece of well-written control, tags. Tags are super important because they allow you to be very specific in your control and to add sections that don't exist. So we're used to saying control, impact, title, description. These are official things that exist within compliance. With tags, you can make up things. You can say tag Muppet, Elmo, boom. Like, you don't have to restrict yourself to just what compliance offers you there. And so tags can be done in either a key value or key format. So you can say like tag SSH, tag prod. You can also say tag remediation : where your remediation is. So these are important also because they get indexed inside of the Chef's compliance server. So when you run your reports, you'll see these tags and information, and you can search for things by tags, and you can say, show me all controls that have SSH in the tag, or just the prod controls, or only controls that have category 3 issues, right? So when we tag things, we're going to do a certain set of tags, and again, they come straight out of the STIG. We're going to map these things, and we're going to tag the vulnerability ID, the rule ID, the severity, the STIG ID, and the remediation. The remediation is incredibly important because this tells me, as an auditor, or as an IA person, or as somebody who just noticed that this turned red, where this is remediated. Where in my system am I going to go to remediate this, right? So this is my mapping here, where I say, oh, look, this issue is fixed in the RHEL 6 STIG in the autofs.rb recipe. Right there is where it's fixed. So I can actually go find that and look at it. So the next thing is a reference. References are special pieces of metadata. They refer to external documents. So with a reference, you're going to be putting a URL here. This URL can be something like the actual location of the STIG document. It can be the location of your own personal internal security document if you want it to be. But what's cool about these references is, again, in Chef Compliance, they actually show up as clickable hyperlinks. So you can go click on it and go find the document. So that's really, really helpful when you're running around going, oh, look, I should have a patching policy. Where's my patching policy? Click, and we can go find it. So there's 2 other tags that we're going to put in here. So I know it's a lot of tags, but we're going to put 2 other tags in here. There are 2 other sections in a STIG control. They are the check content section and the fixed text section. They do exactly what you think they do. One of them tells you what you're supposed to check for, and the other one tells you how you're supposed to fix it. So we're going to add these into our controls. And the reason that we're going to add these in is because this is what tells your developer or your IA team or whoever's going to write your remediation code what they're supposed to look for and how they're supposed to fix it. These sections will change when you triage in your organization, because suddenly the way you fix something becomes different and where you look for something becomes different. And this data is what your development team is going to use to write the remediation for these things. So it needs to be accurate. So I know that's a lot, right? We want to have titles that are very clear and descriptive, very straightforward. We want to be able to map our impacts to certain SEV codes, right? We want to have very clear descriptions and clear metadata that we have that enables our development team to actually write the remediation for these things and enables traceability. And then we want to write some checks. Now, when we write checks, we have this idea of portability. A lot of people who write code are familiar with this idea of portability. For us, what we care about is, can my profile go to different places, right? Now, so this isn't necessarily about STIGs, but it's really cool, and I want to talk about it anyway. So you can ingest data from other sources outside of InSpec. So in this example, I'm reading a flat file that has a list of mount points in it, and I'm feeding that to control in InSpec. And what this enables me to do is it lets me keep lists of things outside of InSpec. You can put it in Redis or Console or wherever your configuration management database is if you want to, right? Because InSpec is based in Ruby, it really frees you up to do a lot of really cool things. So we can read things like YAML and JSON as well. So given the following JSON structure, which just has some packages and their version numbers, I can parse that and go through and figure out not only is something installed, but what its version is, right? So these are helpful things that when you're writing your controls, something you can think about, because sometimes new things come out, new CVEs, new problems come out that aren't necessarily STIG related, but as security teams, we still have to care about, right? So everybody knows that there's this thing called a technical control, which means I actually have to do something, and there's a non-technical control. These are suggestions. These are, hey, you should document this. These are, I think you might want to do this, and they're open a lot to interpretation. You can actually still write controls for your non-technical controls so that you can still report on them. You're not required to write a check when you write a control. Yes, InSpec will scream at you and go, hey, there are no checks here, but it's still going to run. And the reason that you're going to do this, so you're going to create sections. You're going to include all the applicable metadata. So a control that tells you you have to have a document describing your patching methodology. You can have a control with all of that metadata there so that you can go find it. You can, when your report runs and your auditor goes, hey, where's your documentation? You can go, it's right there, Mr. Auditor. This is important because your profile needs to be a single source of truth document for security within your organization. I should not have to go look at 40 documents in a binder to be able to prove that I'm securing things properly. I should be able to look in one place, one run report, look at one dashboard to show me my security posture. So we've written this incredible specification, and now we need to write some code. So who all has had situations where you can't manage the whole file and you have to do an individual line edit in Chef? Anybody? Yeah, a couple of people. It's annoying, isn't it? It's super annoying. So when you implement STIGs, right, there's two ways to do this kind of thing. The first way is that the app dev or environment owners are the ones who are going to do the remediation, right? Your developers, so to speak. The other way is that the IA team is going to write a remediation cookbook, right? Both ways are right. I think everybody can agree that we expect the security teams to write these awesome specifications for us, but it's give or take as to who's going to do the remediation. There's nothing wrong when you're just starting your DevOps journey with having your app dev teams being handed a specification and having them write the security as they write their installation cookbooks. In really large organizations, that is super hard to do. Almost always, the IA team is going to end up being responsible for writing the remediation for this stuff. So when we write remediation, we write chef cookbooks, traceability is still important. We still care about that. And so while we were going to write an individual control per STIG, we're going to combine those in Chef. We're going to combine all of the SMB things into one Chef recipe. We're going to combine all the SSH things into one recipe. And we're going to provide traceability by making sure that we document all of the rule IDs and rule titles in the comments of those Chef recipes. So back to the, it's totally horrible to have to manage the whole file thing. Well, you don't have to, and sometimes you can't. So sometimes you're an enterprise organization and your job is to STIG a box and provide that box to someone else. And they're going to continue to use your security profiles to make sure that the security baseline is maintained there. But they may have to make changes to the sudoers file or to some audit file. And so you can't know what their settings are going to be. And so there's no way you're just going to be able to write a template to manage the whole file, right? It's hard, it's complex, and we really don't need to. So Chef has this cool thing called the Chef file or Chef util file edit that are a bunch of Ruby methods that let you go in and like hand edit, so to speak, a file. So we're going to look at a couple of these. So the first one is search and replace. Actually, this has a bunch of them in it, but we're going to look at search and replace. So when you use the file edit utilities, you have to remember that it's a Ruby block. And so because it's a Ruby block, you have to write your own idempotency stuff for it. But basically what we do here is we're going to open a file. We're going to search in this file for a regular expression, and we're going to replace what we find there. We're asking this thing if there are unwritten changes, right, then we're good. But if there's not unwritten changes, then that means we haven't made a change. And so then I want to insert something. I want to insert something into this file, right? So then I write my file out, and here again, you have to make sure that you have a little bit of dirty idempotency so that you can get these, so they don't run all the time, right? Because you don't want things to repeatedly insert things into files. So here's the same thing. We are going to find a match, and we're going to insert something after this match, right? And here we're using the bash guard interpreter as opposed to using Ruby. So it doesn't matter what guard interpreter you want to use, just so long as you use one, please. Here we're doing another Ruby block. So this is fun because we're actually reading a chef attribute that has a bunch of key value pairs in it. And we're looking for each of those key value pairs to replace within a file to make sure that they're set correctly. So the folks over at Sous Chefs have taken a lot of these and turned it into a cookbook called the Line Cookbook that takes a lot of, not all, but a pretty good bit of these methods and turns them into chef resources. So if you want to play with this stuff, but you're not really into the Ruby thing and you don't want to go there, go check out the Line Cookbook because it will provide you a really great starting point for that. So we've done all this ingesting and specification and triaging and development, and well, we kind of need to test stuff, right? So everybody has heard of test-driven development probably at this point, but the idea is you write tests, then you write code that matches up to the test, and you iteratively write code until all the tests work. Well, so what's really cool about Chef Compliance is your compliance profile is all your tests. You've literally already written all of your test specification right there. So you've done the test-driven development because you've written your entire specification. And so you can use things like Test Kitchen, because you can tell Test Kitchen to read InSpec controls from other places. And you can bring those into your tests. So what's cool here is you can write remediation code, test it as you go. There's also this cool thing called the Audit Cookbook. And so what's cool about the Audit Cookbook is it lets you run InSpec profiles as part of Chef Client Run. So what's great about this is throughout your entire pipeline, whenever Chef Client runs, you can run a security profile. So that means that when you're in dev, you have your security profile running. When you're in test, you have your security profile running. When you're in prod, your profile is still running. So you can catch things in different places. So the last part of this is the ability to be able to certify what you've done. And so for our purposes, what we had to do was we had a requirement that we actually had to sign these profiles. And so at first I was like, okay, we'll do MD5 sums and we'll just match those up because we were air gapping this stuff into a different environment. And it's important, right? We had to prove to the client that the thing that I gave them was the thing that I packaged before. So InSpec has this kind of sort of unsupported feature called InSpec Artifact. I don't know if any of you have played with that. InSpec Artifact allows you to create a signed profile. So InSpec Artifact allows you to generate a RSA key pair. It allows you to sign that profile with the RSA key pair and produce a .iaf artifact. And it allows you to then validate. So I can verify that profile with the public key, which means I can ship my IAF artifact and the public key, and people can validate that, yes, this is the thing it says it is. And then you can install it. So the compliance server doesn't actually support this yet, so you can't install an IAF signed profile to your compliance server. But as part of your pipeline, you can unpack this. So you can take the artifact to the place that you need to install it. You can validate it, you can unpack it, and then you can upload that unpacked artifact up to the chef server. So when we think about, I don't want to be the dam to production anymore. We want to be involved. We want to help, and we want to do it in this low friction kind of way. We're going to break down this thing into these processes, right? We're going to ingest data from not only from the STIGs, but also from our feedback loops, our previous execution runs. We're going to triage this data within our organization because it's vital to make sure that all the stakeholders are involved so that we don't paint ourselves into a corner somewhere. Then we're going to write specifications. We're going to write specifications that are clear, informative, portable, and traceable. And these specifications are going to serve as the basis for test-driven development within our organization. We have to remember that there are lots of ways to implement the STIGs, and you should choose the way that best aligns with where you are in your current DevOps journey. And sometimes you can't manage the whole file, and that's okay. You don't have to manage the whole file. Chef provides you a way to not have to do that. And you have to remember that you should be able to certify your results throughout your entire pipeline, all the way from the developer's workstation to production. And you need to be able to prove that these things are the way they are. Because after all, the mantra of any good security engineer is that security is not a product, it is a process. And that's what we all have to get together and understand. So, thank you very much.
All right, so we've got about 5 minutes for questions. Does anybody have any questions? Would like to bring them around the microphone so we can capture these for people who couldn't attend the session. So we're going to go ahead and start right here.
What's the relationship between CIS benchmarks and the STIGs and the SCAP? How do they all...
So the CIS benchmarks are produced by NIST, and in a lot of ways they are very, very similar to a STIG. So if you think about it, a STIG is the public sector version of a CIS benchmark, right? The CIS benchmarks are a little bit more involved. There's a lot more in them. And but that's kind of where that relationship is. And then as far as SCAP data is concerned, that's also maintained by NIST. And it was they were way ahead of their time. SCAP has been around for quite some time. The Open SCAP project has been around for a while. And what they were trying to accomplish is what we're doing with InSpec and with compliance, was produce a language that you could then automate the remediation of things. And so it's XML based, which is a little annoying for some people, and so that's why people kind of have gravitated towards other projects.
From security perspective, what is the best way to manage secrets in the verification side? For example, I saw in the group message you showing the plain password. So how manage that?
Oh, right. Okay. So the password thing. All right. So so this is something I talked to Dominic about, and they're actually going to produce integrations with things like Vault so that you can store your secrets in separate places. Because InSpec is Ruby based, I've got a demo where I call out to a Redis cluster for stuff, and so long as there's a Ruby gem to call out to Conjure or Vault or whatever you need, you can actually kind of hack your way into that now and manage those secrets outside. You can use profile attributes. There's this cool thing called profile attributes in InSpec where you have like a YAML file and you have a username and password there. It's still plain text because they haven't encrypted it yet, right? But so they're definitely working on different ways to do that. But the hacky way is to download the gem for whatever thing that you're going to use to maintain your secrets and just get at them that way.
Hi. Well, what's your experience been with pushing adoption of this? Because with agencies we've gone into and said we want to use InSpec for all of this, they go, that's fine, cool, show me the Nessus scan. Or it always goes back to show me the Nessus scan. So how have you been able to sort of overcome some of that?
So there's a couple of things. First, Nessus is kind of pricey. Nessus is also super slow, and you can't run it all the time in production. It takes hours and hours and hours and takes systems down. And when you talk about continuous compliance, there's a very good use case there. As adoption grows with InSpec, more and more organizations are going to gravitate towards that. The other problem with Nessus is that they don't really keep up very well with how to remediate things, and even some of the checks are kind of eh. Tenable is, they're helpful, but they're a large organization with a lot of demands on their time, whereas with compliance, something like Dirty Copy on Write, when that came out, I wrote a remediation for it that day and put it online. So that's the kind of benefit you get when you go with compliance or something like that. And as organizations start to move more towards, yes, we're accepting, and yes, we want open source tools, you'll find that it's easier and easier to get it in there. The other thing is like being able to scan all the time in dev, because nobody wants to go install Nessus in dev and run Nessus scans in dev. Like nobody wants to do that. And so like I have a client that has both InSpec and Nessus. They have Nessus in prod and they have InSpec everywhere else.
Where do you document that you've evaluated a state control and it doesn't apply for you? Like you have a small lab and you require AutoFS to get your stuff done. Where do you say that you've looked at it and don't need it?
So as part of your triage process, you're going to have to create documentation, right? You're going to have, because here's the thing, like sometimes you're going to have to like do a POAM or something and like, oh, I'm sorry, I cannot do this, right? When you triage stuff, what you come out with in your profile are the things that you say you're going to apply. So the delta between what your STIG says and what your compliance profile says represents the things that you have said, these don't apply to me, or they don't apply with the way that I'm doing something. Does that make sense?
So as long as it's missing that.
So for our purposes, right, for what I tell my clients is that what's in the specification is what you're doing, and if it's not in the specification, you're not doing it, right? So when you triage, though, every single time the new stuff comes out and you triage, you got to go back and look at that and say, okay, are we doing this now? Because if we are, now we have to add that to our profile. If we're not, we can continue to leave it off.
All right, with that, we've reached the end of this session. Just one more round of applause for John. Thank you so much. Thanks for attending.